Hi there, Miss Barber here. This example involves finding an area bounded by trig functions. Find the area bounded by y equals cosine x, y equals cosine 2x, x equals 0, and x equals 2 pi over 3. We first begin this by having a review on how to solve a trig equation. How about cosine x equals cosine 2x? And we'll restrict that x is an element in the closed interval from 0 to 2 pi over 3. First, we're going to use a double angle formula for cosine 2x and rewrite this equation as cosine x equals, and for cosine 2x, we'll use 2 cosine squared x minus 1. Now let's set this equal to 0. I'll subtract cosine x from both sides, so the equation becomes 0 is equal to 2 cosine squared x minus cosine x minus 1. Then we can factor the quadratic type. We'll get 0 equals 2 cosine x plus 1 times cosine x minus 1. We have two separate equations to solve for x. Let's begin with 2 cosine x plus 1 equals 0. Solve for the cosine. Cosine x equals negative 1/2. And so x answers the question, cosine of what equals negative 1/2, and in the interval from 0 to 2 pi over 3? It turns out to be 2 pi over 3. And notice that's one of the bounds of integration. Let's solve cosine x minus 1 equals 0, adding 1 to both sides. Cosine x equals 1. Cosine of what equals 1 in the interval from 0 to 2 pi over 3? It turns out to be x equals 0, and that is also one of the bounds of integration. Now back to the problem at hand. Find the area bounded by y equals cosine x, y equals cosine 2x, x equals 0, and x equals 2 pi over 3. Let's begin this by sketching the graphs. The graph of cosine x is drawn solid. The graph of cosine 2x is drawn with dashes. And we want the region bounded by x equals 0 to x equals 2 pi over 3. We previously solved for the points of intersection. They were x equals 0 and x equals 2 pi over 3. The area we want to solve is bounded on the top by y equals cosine x, the bottom by y equals cosine 2x, and from x equals 0 to 2 pi over 3. So, setting up the integral, it'll be the integral from 0 to 2 pi over 3 of cosine x, the top function, minus cosine 2x, the bottom function, dx. Let's find the integrals. The integral of cosine is sine, and we'll do minus the integral of cosine 2x is sine 2x times 1/2, and we evaluate that from 0 to 2 pi over 3. That means we put 2 pi over 3 every place there's an x. So we'll have the sine of 2 pi over 3 minus 1/2 times the sine, and we've got 2 times 2 pi over 3, so that'll be 4 pi over 3. Then we subtract it with the sine evaluated at 0. Minus sine of 0, and then still in the brackets minus 1/2 sine of 0. Let's evaluate these. The sine of 2 pi over 3 is square root of 3 over 2 minus 1/2 times the sine of 4 pi over 3 is negative square root of 3 over 2. Then we need to subtract. The sine of 0 is 0, so evaluated, it's just minus 0. Continuing, We got square root of 3 over 2. Negative and negative gives us a positive, so that's square root of 3 over 4. Getting a common denominator and adding these two terms, the area is 3 times the square root of 3 divided by 4.